All right, I hope you had a great Easter break, but now we are ready to get back in focus. Remember, if you guys have a good week, you work hard Monday through Thursday, we'll have a fun activity on Friday. If I get bad notes from the sub, we won't have a fun day on Friday. We'll do some more worksheets instead. Okay, so your bell work was on page 665, and I asked you to do the vocabulary startup. So it says, recall that the graph of a linear equation is a line on the coordinate plane. The slope of the line describes the direction and the steepness of the line. On the coordinate grid shown, graph and label two lines. One line should have a positive slope and one line should have a negative slope. So all you needed to do was draw in two lines. So my blue line is going to be a positive slope because it's going uphill. And remember, when you're reading graphs, you're reading from left to right. So my line is increasing from left to right. My red line is a decreasing slope because, again, I'm still reading it from left to right and it's going downhill. Okay, so that was your bell work. We're now going to go over the real world link on that same page. So in the real world link, it says the table shows temperatures in degrees Celsius and the corresponding temperatures in Fahrenheit from a local weather station. Graph the ordered pairs, Celsius, degrees Fahrenheit. Is the slope of the line passing through the points positive or negative? So you need to make sure that you are graphing these with me in your book. So you can see our Celsius is our X, and our Fahrenheit is our Y. So we're going to go to where it says 0, 32. So I'm going to go to 0 and up 32. It's about right there. Okay. My next one is 5, 41. So I go over right to the 5, and then I go up to 41. So we can't do exact because we don't have the exact points, but we can do our best guess. I'm going to go over 10, up 50, over 15, over 15, up 59, so almost at 60. Over 20, up 68. Over 25, up 77. And over 30, up 86. Okay, so that is our ordered pairs that we've graphed. If we drew in a line here, would we say that line is increasing or decreasing? We would say it's increasing so that we would have a positive slope. So our answer to that question was positive. All right, we're going to go ahead and flip the page and talk about some vocabulary. So up at the top, we're going to talk about constructing a scatter plot. So it says data with two variables or pairs of numerical observations are called bivariated data. Okay, bi means two. Because when you have a bicycle has two wheels. Bi means two, bivariated data, so data with two variables. A scatter plot shows the relationship between bivariated data graphed as ordered pairs on a coordinate plane. For example, the bivariated data set for year and number of visitors can be displayed as a scatter plot. Okay. In example 1, we are going to go through. All right, sorry, I wanted to get a blank graph so that we can walk through this example together. So in example 1, it says construct a scatter plot of the number of viewers who watched new seasons of a certain television show. So we need to, you look in that table, we have seasons, and then we have viewers in millions. Our first column is going to be our x's. So the first thing we have to make sure that we do is we need to label our x-axis. So the label would be seasons. And then our y-axis would be labeled viewers. And you need to make sure that you write what you are talking about. Is it one viewer? Is it two viewer? Ours is millions. Okay, so first thing we label our x and y axis. Then we're just going to graph our plots. So my x is 1, my y is 31.7. So on my graph, I actually have to go through and label. So we're going to say this one is 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up by 10. So 10, 20, 30, 40, 50, 60. Okay, so again, sorry, we're going to label it 1. So we're going to go over 1 up to 31.7. Over 1 up to 31.7, put a dot. Okay, we're going to go over 2 up 26.3. Over 3 up 25. Over 4 up 24.7. Over 5 up 22.6. Over 6 up 22.1. Okay, so there we've constructed a scatter plot. In your book, you need to do Got It A with me, so make sure you're writing down what I'm writing down. Remember, the first thing we need to do when constructing a scatter plot is to label our x and y axis. We are going to use weeks as our x and our weight as y. At 0 weeks, and we need to label our axis, so this is weeks, and this is weight in pounds. Okay, so we labeled. At 0 weeks, it was 6 pounds. At 9 weeks, it was 8.6. At 18, it's 10. So you notice that there is no 18 on your x-axis. That means you're going to have to go in between 15 and 20, and then you're going to go up to 10. On 27, again, in between 25 and 30, we're going to go up to 13.6. Over 34, up to 15. Over 43, up to 17.2. And over to 49, up 19.5, or 19.8. Okay, so that is our scatter plot. Now we are going to talk about some more vocabulary and describing these scatter plots. So some vocabulary that we need to know are types of association. So when we look at a scatter plot, we want to be able to see, does this scatter plot have a linear? Is it nonlinear? Is it no representation of the data? Is it random? Is it what kind of uniform or what general statements can we make when we look at this scatter plot? So there are different types. So we have variable association and linear association. When you're talking about variable association, you have 3 options. You can have a positive association, a negative association, or no association at all. When we talk about a positive association, we can say that most of those scatter plots or most of those dots go up in a linear or go up. They are always increasing. Okay? You notice that when we graph our scatter plots, we don't ever connect the dots. We don't connect our lines. It's not a line graph, it's a scatter plot. So it's just random dots on the graph. But you can see that this general group of dots goes up in a positive manner when we're reading from left to right. Then you look at the negative. This general dots go in a down or in a negative association when we're reading from left to right. If you look at our last picture, there's none that are general going up, there's none that are generally going down. It's all kind of just random. They're just everywhere in that graph. There's no association. There's nothing that we can say. They're just kind of everywhere. So that's no association. We can't really make a general statement about that. So that is our variable association categories. Now when we have a positive or negative association, we can also say whether it's linear or nonlinear. If it's linear, the general dots are going to go in a generally straight line, because linear means line. If it's nonlinear, you see how this kind of has a curve before it goes up? So it's still a positive association, but it has a curve to it. So we would say it's nonlinear. Again, it's the general idea of the dots and the shape that they make. The last little bit of vocab that we need to talk about is going to be outliers and clusters. So it says you can analyze the shape of the distribution of a scatter plot to investigate patterns of association. If the distribution shows a positive or negative association, then the distribution can be classified as linear or nonlinear. That's just what we talked about. The scatter plot below shows a positive nonlinear association. So you can see the general idea of these dots go up, but they kind of curve to them. They're not in a straight line. So they kind of have a bit of a curve to them. So they are positive because they go up, but then they're nonlinear because they have a curve to them. We also, though, in this graph, have what we call an outlier. So this guy out here isn't near the rest of the scatter plot data. So this is an outlier. He's out here by himself. A cluster is going to be where you have a large collection of them. So there's a large group of them right there. So they're clustered together. So we have outliers out here in no man's land, and we have clustered where they're all scrunched together. All right, so I'm going to go ahead and skip to the next page. So I'm on 668. And I'm going to do Got It B and Got It C with you guys. So on Got It B, it says, interpret the scatter plot of the data for the time elapsed and the temperature of the water based on the shape of the distribution. So if we look at this graph, first of all, we need to talk about the variable association. Remember, with variable association, you have positive, negative, or no association. So if we look at this data, it is generally going downhill. So we would say, when we're reading our graph from left to right, so we would say that this has a negative association. Okay. Then when we have a negative association, we can also say that it's either linear or nonlinear. And if you look at all of this information, it lies really close to that line. No, it doesn't make an exact straight line, but you can see all of those data points fall really close to that line that I drew, and that's a straight line. So we would say that this is also a linear association. Now, when it talks about interpreting it, that means when we interpret the x and the y. So we could say that as time elapses or as time goes on, the temperature decreases because my temperature goes down as the time gets longer. So we would say temperature drops as time goes on. So that would be all of the information that we need for Got It B. All right, I have to stop here because my recording is going to shut off, but you're going to play the next recording and we're going to do Got It C together.